This is an interesting and tricky question. It is June 16, paper 1, 2, and question number 36. There are some aspects of this question that we need to understand. First of all, they said the cell has a constant electromotive force and it also has the internal resistance. So we need to draw the internal resistance which is missing here. Okay, we have drawn that. Now in the question, they are saying that if terminal Z is moved downwards towards X, what will be the effect on the voltmeter reading? So this is a question basically. First, we need to understand what will be the effect on the load or the combined resistance of the circuit when terminal Z is moved downwards. This is what we have to understand first. So to understand this, we have to focus on this thing that if we have a resistor connected here, say this is terminal Z and this is terminal X, and when Z is moved towards X and it is at the extreme position, say exactly at X, then what would be the situation? So we have moved C to the bottom extreme and here we have X. We have to find the combined resistance, or we can say that the resistance between, say this is point A and this is point B, this is point A and this is point B. Let's take some simple values to make the question easier. Let's suppose this was a resistor of 10 ohm and this was a resistor, we are supposing the values just for the sake of understanding. This was a resistor of 20 ohm. Now, if this was the resistor of 20 ohm, the upper part will be of 10 ohm, the lower part is of 10 ohm. The equivalent circuit in this case will become 10 ohm above, 10 ohm below, because the other resistor is in the middle. This is also 10 ohm. The circuit will become like this. And the combined resistance between AB will become, the resistance of this part will be 5 ohm. And for the series circuit, the overall resistance AB will become kind of 15 ohm. Now, when we have moved this terminal to X, this 10 ohm is a short circuit. This 10 ohm is a short circuit. And the remaining part of the resistor, this is 20 ohms. So now R combined or RAB will be 20 ohm because no part of 20 ohm is in parallel. So you'll get fully 20 ohm. If you understand all of this, well and good. Otherwise, one thing that you must know is that when terminal Z, when terminal Z is moved towards X, the combined resistance, the combined resistance, the combined resistance increases. The reason for increase is that the part of this resistor, resistor X, that is the part of resistor X that is parallel to capital R will decrease. The shaded part will decrease. You have to focus on this. When it is moved downwards, the shaded part will go on to decrease. That will result in an increase of the combined resistance. Now, as the combined resistance increase of circuit resistance, that is actually are combined will result in lowering the current. Less current means less voltage lost inside the cell. Now, if the losses inside the cell are decreasing, then for the cell we can write the equation. The equation can be written as the cell is not ideal but it is real. It has the internal resistance. So the voltage or the TPD of the cell will be, this is smaller r, and this is the voltmeter. Let's suppose this is the EMF is E, and this is the part of the circuit containing the cell. Now the current through the cell, it will be coming from the negative terminal and it will be leaving from the positive terminal because the cell is being used and not being charged. What would be the formula for V? V will be equal to E minus IR. So the voltage generated minus voltage lost will be equal to the TPD or the voltmeter reading. Now one thing is obvious. As the terminal Z is moved towards X, the load or the external circuit resistance will increase. With the increase of R, I will decrease. With the decrease of I, the lost voltage will decrease and the TPD will go on to increase. Now we have to see which option is about this. The first option is the voltmeter reading decreases because the current through the cell decreases. The voltmeter reading is not decreasing, but it is increasing. Not decreasing, but it is increasing. The voltmeter reading increases because the current decreases. This is wrong. This one is correct. So C should be the answer. It was a tricky and difficult question.